All right, so 4.1. So in this lesson, we're going to use the Matter and Energy and Ecosystems modeling tool. I don't know why it says simulation. It's actually the modeling tool. Scientists often use models to work out their ideas and share them with others. Next, you will evaluate two models made by students to determine which one is more accurate. You're actually going to make your own models. Two 7th grade students, Molly and Liam, made models to show where the energy storage molecules in an ecosystem come from. In these models, these symbols and colors represent the parts of the ecosystem. So we have a yellow circle for the sun, we have a blue square for the air, and we have a brown square for dead matter. Okay, those are going to be important because you're going to be using those in the model. You're also going to be using these symbols for matter and energy. You will have a little explosion for energy, a diamond for carbon dioxide, and what I think looks like a chocolate chip cookie for energy storage molecules. I think it's supposed to be carbon. Maybe like little carbon molecules. I don't really know. In these models, these arrows show the movement of matter or energy between the different parts. So you're going to show how the light energy moves, the carbon dioxide moves, and the energy storage molecules move. You're going to also show the processes that are taking place in the population. We will only be working with photosynthesis today. We have not started doing anything with cellular respiration yet. Each process has an input and an output box. So in this example, the student is showing one input of photosynthesis is energy, right? You need energy for photosynthesis to occur. On the next two slides, you're going to see Molly and Liam's models. You can use these slides as a reference while working on your own models. Oops. This is Molly's model. Molly's model, the goal is to show where the energy storage molecules in an ecosystem come from. So here you have the biotic, which is the sun. I'm sorry, that's a lie. This biotic line means everything below it is biotic, and then this square up here is abiotic. So here's the sun being transferred, the movement of the energy into the producer. We have the process of photosynthesis. Not so sure her model's correct, right? So we have an input. We're putting in energy storage molecules. Is that right? Do we put in energy storage molecules to photosynthesis? No, we get energy storage molecules out. So Molly's model is not exactly correct. She also has this carbon dioxide going from the producer to the air. Is that correct? No, right? The producer takes in the carbon dioxide, okay, and then puts out the energy storage molecule. So it doesn't look like Molly did such a good job. Here's Liam's model. Liam has the sunlight going in, has the carbon dioxide going in. Good so far? Good so far. And in the producer cell, he has photosynthesis occurring. Good. Into photosynthesis, he has carbon dioxide and energy. Yep, so good. And coming out, he has energy storage molecules. Not too bad, right? Liam's model's pretty good. Hint, hint. So you're going to go to Google Classroom and you're going to open up the number 2 for today, which is modeling energy storage molecules. All right, so once you get your number 2 open, you're going to see 2 documents very similar to what's here on the screen. All you have to really do is carefully take a look at the 2 models, add any comments to each model, explaining whether you think the model is correct or incorrect, and then you have some questions to answer on the second page. If you go back in this video, I did talk about both Liam and Molly's model, and that might help you to kind of look at those a little bit more carefully. You want to pay attention to what's going into the process of photosynthesis and then what's coming out of photosynthesis. Remember, going into photosynthesis, we need energy from the sun, carbon dioxide, and then coming out of the process of photosynthesis should be energy storage molecules. When you're finished, you should turn your work in, and that would be it for today.